Alright, I think we are live, although there's no data. What is that? Well, I'm going to assume that we are live. I'll keep an eye for it. We're a bit late, a couple of minutes, but that's fine. Yep. Alright, what do we have? For example, so example is very short, so that's fine. Let's take that example and let's go here. Well, this is a bit messy. Let's just open a new one. MKD 6 touch max input. Also, yeah, I cannot hear anything. It's fine. Inputs dot base maybe. Yes, that is our base, and what is our full input? That is going to be that one. Not too different, but to do with what you need to do. What is going on here? Just give me 1 second. Full screen. Where is my full screen? Right here. All right. That is the main one. Then main.go. Advent. We have the thing. And let's open again the input base. We have a time, but it's just 3 ints and distance. I think the input was pretty much the same. It is 4. So basically, we can have like as many entry as we need. So that's going to be basically like times and distances. That's going to be string. That is going to be an int. That is going to be an int. And so for each line, basically we have only 2 lines. So we can basically say that if I equal 0, CFD of time equal append of numbers. Continue. Otherwise, we can do the same thing but with distance. That's not exactly what I expected to do. Distance is int with bracket. Alright, and something here, distances. So now we need to actually calculate, first to parse the stuff. That should be quite simple. We have var numbers, which is going to be a list of int. Then we can go over strings that split. We're going to first split on the column, because we basically know the format is going to be 2. That is going to be our line. That is going to be split on column. And that thing itself, we're basically going to take the first one because we know the format, and we're going to resplit that on space. And here we can say, of course, if lm equal space, we continue. Otherwise we basically, if we don't continue, then we do a number equal append of lm, and that should be it, I think. Except, of course, I forgot to parse it. That would do it. And error, let's go directly with skip the error management. Not really good, but that's fine. I'm tired. Want to go to bed. So here's going to be your lm. and here it is n. Numbers, if that is going to be actually equal numbers directly, not happening. And finally, in our input, I mean, we don't really need that. Equal. Okay. Now, what do we do with those numbers? Where is my subject? Yeah. Come on. What do we need to do with this? This document describe 3 races. The first race lasts 3 milliseconds. 15. Okay, why not? Your toy bot has a starting speed of 0 meter per minute second. Okay. Each milliseconds you spend at the beginning of the race holding down the button. Okay, so 1 meter per second. Okay, I'm not so sure what. Okay. Your first race lasts 7 milliseconds, you only get a few options. That makes sense. Indeed, the first race lasts this guy, but why we have the distance then? Basically, we need to find the speed. Not really sure. Okay. So we are looking for 4, 8, and 9. We are looking. Okay. So back to our code. Those numbers have some meaning-ish. We don't want to actually keep track of that. We want to keep track of races. And what is a race? Type race struct. But we do the same thing, but instead of being in one direction, it is in the other. That is going to have like a time and a distance. Pretty sure everything is just going to be ints. Here we have our numbers and our time, so we can say basically like group times var times int, and of course the distance is 2. Now we removed it from the parser because we will not keep it. And when we reach this point, then we go over every one of them. So basically like I t range times, and we can do our d dot races equal happen, and we can create a new race that is going to be of time t and of distance distances of I. Probably should check for bounds, but hey, it is just for fun today. Success. So we compiled, everything is fine. We have the data still, and now we want to check every single possibility. Well, that is should be fine. Func air race that is going to return times possible distances. Let's create candidates. Candidate is that is going to be an int, and it's just going to be for oh yeah, that is going to be a bit annoying actually. We need to actually process the speed. So we say that if yeah, the time is 0, then we don't have candidates. We will always have candidates. We will do then for I 0 all the way up to half time. So basically every one of them that is going to be one candidate. Group candidate. And what that is going to be, we want to know the distance. So for ms at basically here we want to calculate the distance that we can travel in I milliseconds, knowing that for each milliseconds that we press, we are going for 1 milliseconds for 6 milliseconds. Let's just play with that a little bit. Let's just play with that, so we can say that for each step let's create D for duration. Then we can go for I is 0, while I is less than D, I plus plus. And the first thing we do, basically D is a duration for the acceleration. So we need to need the velocity. And the velocity is going to increase every time. Every time we keep it pushed, we increase the velocity. And every time, of course, we also do candidate plus equal v. And I think I'm missing a dimension right there. We hold for 2 seconds, it gives us a speed of 2 millimeters. Why did I want to do that thing again? Yes, because for each one, that's very stupid. Okay. And so. We have R of distance. Is if R of distance is bigger. Oh, excuse me. If R of distance is all the record is lower than our candidate, then or like a result plus plus. Yes. But I am still missing something because no. Come on, so here we go from we are the like that whole thing is basically just trying for the milliseconds and still okay. So we work on the dates. And now we can do for I from equal 0. I is lower than half of time. It's basically like with the candidates, now we rerun the race. The velocity is also at the start. And actually this is not a loop, this is going to be a check if I is less than D, then this, and then the candidate like that. Then we can do here like that. And now we need our n, that should be it. And let's see. Candidate, it doesn't like candidates because I forgot my debug. Success, but it doesn't do anything because that is never called. And why is that never called? Because run does not do anything. Fair enough. That is going to be our races. Of 0 dot candidates. Let's try that. Dot base. Okay, so now it tells us 5 and we're actually expecting 4. So that is a bit annoying, but not a big deal, not a big deal, not a big deal. We can always do fmt printf candidate is this guy. So when we are at 0, the candidate is at 0, that makes sense. When we're at 1, oh, we should be at 6 only. Why were that plus 1? I guess we should do the inclusivity later. So that is 6, 11, 15. Nope. Okay, so it's 1 or 0 there. 1 or 0 there. It is not both at the same time. It's not a question of order. It's just there is no nothing here. So okay, we have our 4. Now what if we do it in a loop? Actually, let's do that for lm d of races. lm dot candidates. So that will be 4, 8, and 9. And what were we looking for? Let's remember it's exactly that. So that is quite encouraging. Now let's try the full one. Not going to that by head. So where is our candidate thingy? Now we need to aggregate the candidates, but no. No, that is just going to be one candidate for one race. Candidate counts. Whatever, the name is not important. What is important though is the fact that we have this guy here. That's supposed to be working, it still does. Candidate, so we have what do we have for? Oh yes, and oops, and congrats 1 n times equals this guy empty printf res. That should be our solution. Let's see if we got it right. And we did. Awesome. Now, as the race is about to start, we realize that the piece of paper with the race times record distance earlier actually just has a very bad kerning. What is kerning, I don't know. There is really only one race. Ignore the space between the number on each line. What? Okay, why not? That may be a bit slow, but I mean, it should be working just fine. It may take some time. Let's start with the base to try that. Then we can go to our parser. Parser. And here we have our split of this. And we can simply do part 2 merge. We can do that align equal at strings dot replace all of our line space with nothing. 71501 503 exactly. That is me. It'll take a long time. I mean, just thinking about just yesterday, like how long it took like to run everything. But okay, let's give it just a few minutes to see like if it actually does something. In the meantime, we can still like try to think on how that could be optimized. Because I think now we already start to reach this point where we really need to think and not just do. So a bit more demanding than what I was expecting when I got started, but that is fun. That is fun. So that is a parsing, and those are candidates. There is probably, oh my gosh, because here, like here, what is that number? Look, it is ludicrous. I should have at least a progress bar or something. So I'm going to try for that much time. And for that distance. And the distance is not that important, but I guess for the distance we know that we need to start at the distance. No? No. Well, not going to do like last night and stay until 4 a.m. Still tired from the time. Just going to leave that running. Pretty sure it's going to work. Maybe going to take a few some time. Going to take a break. I'll take a look before going to bed. And well, maybe tomorrow night we can try to go back over the couple of previous days and clean up and optimize and yeah, try to see what happened. In any case, thank you for watching and I'll see you next time.